An anti-short bushing is typically required on the end of the metal casing of a capacitor. This is done to ensure electrical isolation from adjacent components. The primary function of an anti-short bushing is to prevent short circuits. It achieves this by preventing the conductive elements of the capacitor from coming into contact with other conductive surfaces or components. The bushing effectively acts as an insulating barrier. This insulating barrier is critical for ensuring the safe and reliable operation of the capacitor. Without an anti-short bushing, the risk of a short circuit significantly increases. A short circuit can lead to equipment damage, fire hazards, and potential injury. The bushing minimizes these risks by maintaining a physical separation between the capacitor's internal components and the surrounding environment. The material of the anti-short bushing is typically a non-conductive plastic or rubber compound. This material is chosen for its high dielectric strength and ability to withstand voltage stress. The design of the bushing ensures that it can effectively insulate the capacitor's terminals and casing from accidental contact with other conductive parts. The installation of an anti-short bushing is a straightforward process. However, it is essential to ensure that the bushing is properly seated and secured to the capacitor casing. A loose or improperly installed bushing may not provide adequate protection against short circuits. Regular inspection of anti-short bushings is recommended to ensure their continued effectiveness. Over time, bushings can degrade due to environmental factors such as heat, moisture, and vibration. Damaged or worn bushings should be replaced immediately to maintain the integrity of the electrical insulation. Anti-short bushings are commonly used in a wide range of electrical and electronic applications where capacitors are present. This includes power supplies, motor drives, lighting systems, and industrial equipment. The use of anti-short bushings is often mandated by electrical safety standards and codes. These standards specify the minimum requirements for electrical insulation and protection against short circuits. Compliance with these standards is essential to ensure the safety of personnel and equipment. The selection of an appropriate anti-short bushing depends on several factors, including the voltage rating of the capacitor, the size and shape of the capacitor casing, and the environmental conditions in which the capacitor will be used. It is important to consult the manufacturer's specifications and recommendations to ensure that the correct bushing is selected. In addition to preventing short circuits, anti-short bushings can also help to reduce electromagnetic interference. By providing a barrier between the capacitor and other components, the bushing can minimize the radiation of electromagnetic energy. This is particularly important in sensitive electronic equipment where electromagnetic interference can disrupt performance. Anti-short bushings are a critical component in ensuring the safe and reliable operation of capacitors. Their function in preventing short circuits and providing electrical isolation is essential for protecting equipment and personnel. Regular inspection and maintenance of bushings are necessary to ensure their continued effectiveness. The use of anti-short bushings is often required by electrical safety standards and codes. Adherence to these standards is paramount for maintaining a safe electrical environment. When working with capacitors, it is always important to follow proper safety procedures. This includes wearing appropriate personal protective equipment such as gloves and eye protection. It is also important to ensure that the capacitor is properly discharged before handling it. Capacitors can store a significant amount of electrical energy, even after the power supply has been disconnected. Failure to discharge a capacitor before handling it can result in a dangerous electric shock. Anti-short bushings play a crucial role in mitigating this risk by preventing accidental contact with the capacitor's terminals. The design and construction of anti-short bushings have evolved over time to meet the increasing demands of modern electrical and electronic equipment. Advances in material science and manufacturing techniques have led to the development of more durable and effective bushings. These advancements have contributed to improved safety and reliability in a wide range of applications. The use of anti-short bushings is not limited to capacitors. They can also be used to protect other electrical components such as transformers and inductors. In these applications, the bushing serves the same purpose of preventing short circuits and providing electrical isolation. The principles of selecting and installing anti-shot bushings are the same regardless of the type of component being protected. It is always important to consult the manufacturer's specifications and recommendations to ensure that the correct bushing is used and that it is properly installed. Anti-shot bushings are an essential part of any electrical safety program. They provide a simple and effective means of preventing short circuits and protecting equipment and personnel from electrical hazards. Regular inspection and maintenance of bushings are critical to ensuring their continued effectiveness. By following proper safety procedures and using appropriate anti-shot bushings, you can significantly reduce the risk of electrical accident. It is important to remember that electrical safety is everyone's responsibility. By being aware of the hazards and taking appropriate precautions, you can help to create a safer working environment. Anti-shot bushings are just one small part of a comprehensive electrical safety program, but they play a vital role in preventing accidents and protecting lives. The consistent application and maintenance of these bushings are paramount for safety. Let's further explore the technical aspects of anti-shot bushings and their application in electrical systems. We will delve into the materials used, the standards governing their use, and best practices for installation and maintenance. Firstly, the materials used in anti-shot bushings are critical to their performance. As mentioned earlier, these bushings are typically made from non-conductive materials such as plastic or rubber compounds. These materials must possess high dielectric strength, meaning they can withstand high voltages without breaking down and allowing current to flow. Common plastics used include nylon, polycarbonate, and PVC. Rubber compounds often include neoprene or silicone, chosen for their flexibility and resistance to environmental factors like heat and moisture. Secondly, the standards governing the use of anti-shot bushings are primarily set by organizations like the National Electrical Code (ONEC) and Underwriters Laboratories (ORL). The NEC provides guidelines for safe electrical installations, while UL tests and certifies products to ensure they meet safety standards. These standards dictate when and where anti-shot bushings are required, as well as the performance criteria they must meet. For example, the NEC might specify that any metal enclosure containing electrical conductors operating at a certain voltage must have bushings installed to protect the conductors from abrasion. Thirdly, best practices for installation and maintenance of anti-shot bushings include proper selection, careful installation, and regular inspection. The bushing must be appropriately sized for the opening it is intended to protect, and it must be made of a material suitable for the environmental conditions. Installation involves securely fitting the bushing into the opening, ensuring it is flush with the surface and provides complete coverage of the sharp edges. Regular inspection should be conducted to check for any signs of damage, such as cracks, wear, or deformation. Damaged bushing should be replaced immediately to maintain the integrity of the electrical insulation. Furthermore, the effectiveness of an anti-short bushing depends on its proper application. It is not simply a matter of slapping a bushing onto any exposed edge. The bushing must be specifically designed and rated for the voltage and current levels present in the circuit. It must also be compatible with the materials of the enclosure and the conductors it is protecting. For example, a bushing made of a material that is chemically incompatible with the enclosure could degrade over time, losing its insulating properties. In addition to preventing short circuits, anti-short bushings can also help to improve the overall reliability of electrical systems. By protecting conductors from abrasion and damage, they can extend the lifespan of the conductors and reduce the risk of insulation breakdown. This can lead to fewer maintenance issues and reduced downtime. The selection of an anti-short bushing should also take into account the specific application requirements. For example, in applications where there is a risk of exposure to corrosive chemicals, a bushing made of a chemical-resistant material should be used. In applications where there is a risk of exposure to extreme temperatures, a bushing made of a heat-resistant material should be used. It is also important to consider the mechanical strength of the bushing. In applications where there is a risk of mechanical stress or impact, a bushing made of a strong and durable material should be used. Anti-short bushings are not a one-size-fits-all solution. The correct bushing must be selected for each specific application. The proper installation of an anti-short bushing is also crucial for its effectiveness. The bushing must be properly seated and secured to the enclosure. If the bushing is not properly installed, it may not provide adequate protection against abrasion and short circuits. It is also important to ensure that the bushing does not interfere with the proper functioning of the electrical system. For example, the bushing should not obstruct the flow of air or create a point of stress on the conductors. The regular inspection and maintenance of anti-short bushings are also important for ensuring their continued effectiveness. Bushings should be inspected regularly for any signs of damage, such as cracks, wear, or deformation. Damaged bushings should be replaced immediately. It is also important to ensure that the bushings are kept clean and free of debris. Dirt and debris can accumulate on the bushings and reduce their insulating properties. Anti-short bushings are a critical component of electrical safety. By preventing short circuits and protecting conductors from abrasion, they help to ensure the safe and reliable operation of electrical systems. The proper selection, installation, and maintenance of anti-short bushings are essential for maximizing their effectiveness. As technology advances, the design and materials of anti-short bushings continue to evolve. New materials and manufacturing techniques are being developed to improve the performance and durability of these critical components. These advancements are helping to make electrical systems safer and more reliable than ever before. In conclusion, anti-short bushings are a vital component in electrical systems, primarily serving to prevent short circuits and ensure electrical isolation. Their proper selection, installation, and maintenance are essential for maintaining the safety and reliability of electrical equipment. By adhering to industry standards and best practices, one can significantly reduce the risk of electrical hazards and ensure a safe working environment. The use of appropriate materials, adherence to safety standards like the NEC, and consistent inspection contribute to the overall integrity of electrical installations. Remember that anti-short bushings are not just an accessory but a critical safety device, and their proper implementation is paramount for protecting both equipment and personnel from potential electrical dangers.